Okay, so I'm continuing these videos where I'm doing every exam question that has ever been asked, and we're now going to be looking at linear graphs, and in particular we're going to be looking at regions. Now if you want to use this document, it is going to be linked in the description, and so you can follow along with me. Okay, so for this one here, it says we want to write down the three inequalities that define this shaded region that we've got here. So to begin with, we're going to see if we can name these lines that we've got. And I'm going to begin by naming this line here, which I think looks like a pretty easy one. You can see that it's going through the origin, and every time you go one space across, you're going one space up. So this one just has a really simple equation. We know that it's just y equals x because the gradient is 1, so y equals 1x, and there's no y-intercept. Then we've got this other equation, which I think is probably just as easy. This one that we have here, it is a horizontal line passing through -2. That is y equals -2. Now the last one that we need to think of is this one that's going on here. So we're going to do two things. We're going to see that the y-intercept is 1. So I know that there's definitely going to be a +1 that's coming at the end. All we need to do now is figure out what the gradient is. Now, if I take that line, I can see that it's crossing at these 2 points. If I draw on a triangle here, we can see that the rise is 1 and the run is 2, meaning there's 1 square here and 2 here. And you do the rise divided by the run, so 1 divided by 2 is a half. So this one is y equals a half x plus 1. All we need to do now is define the region by adding in some inequality signs. Now, first of all, let's look at this one. We can see that clearly the shaded region is above this line, which means that y is greater than or equal to -2. The reason I've used greater than or equal to is because the line is solid. If it was a dotted line, you wouldn't have the or equal to sign. The reason it's above is because we're saying that the y-coordinate is above. The y-coordinate is greater than -2. Now for the second one, the y equals x, you can see that it's above that line, and we're saying that the y-coordinate is greater than or equal to the x-coordinate. So basically concentrate on the y part. If it's above the line, it's greater than, and if it's below the line, it's less than. And so for this last one, we can see it's below this line, which means that y is less than or equal to a half x plus 1. So these are the three inequalities that we want here, but you'd get some marks for identifying them, even if you got these signs here incorrect. So we've got y is greater than or equal to -2, y is greater than or equal to x, and y is less than or equal to 0.5x plus 1, but of course we could also do that as a half x plus 1 as well. This time we're going to do some drawing here, and you'll notice all of these signs are just less than or equal to or greater than or equal to. They don't, sorry, not or equal to, just less than or greater than, which means when we draw them, technically we should be doing it with dotted lines. You'll see in some of the mark schemes later that they're not that fussy about this, but this one it doesn't mention it. So first of all, we're going to draw the line y equals 1. Now the line y equals 1 is just going to be a horizontal line going through 1, and you'll notice I'm drawing it as a dotted line then. Now my next one I'm going to do is this one, which I think is a bit easier, which is our y is equal to 2x. I'll tell you what, I'll do that one in a different colour so that we can see what's going on. I'll do that one in like a red colour. So I'm going to just draw the line y equals 2x. That just means it's going to go through the origin and it's going to have a gradient of 2. So when you go 1 across, it's going to go 2 up. So it's going to go through these points that I've just marked on here. And now I'm just going to make that become a dotted line. Obviously, you could do this using a ruler just to make sure that it's more accurate than what I've done. And then the last one that we've got is our x plus y is less than 5. So x plus y, I'm going to say that it's equal to 5, and I'm going to show you the way that I think about doing this one. You could rearrange it, and if you rearrange it, you get y equals -x plus 5. So we can just say it's going to have a y-intercept of 5 and a gradient of -1. Or what you could do is you could say, okay, well, let's find out what happens when x is equal to 0. Clearly, when x is 0, y is 5, which gives us this point here. When x is 0, y is 5. And then we could say, what about if y was equal to 0? Well, x would be equal to 5. So that would be this point over here. Then all you need to do is just join them together, and you'll see it is going to be a line with gradient -1 that is passing through 5. Now we just need to decide whether it's going to be above or below the line. So this one's really easy. Y is greater than 1. That means it's going to be above this line that we've got here. This says that y is greater than 2x. That means the y-coordinates are going to be above that line. This one's a bit trickier. It's saying the x plus y is less than 5. Well, it's saying that the x and y-coordinates are less than 5. That means it's going to be below this black line that we've got here. So the only area that's going to be all three of these bits, where it's going to be above the blue and to the left of the red line and below this one, is this whole section that we have got here, and it says to label that area R. So let's check that we've got this one right. Yep, it's this section that we've got here, and we've got all of these bits drawn in correctly. Okay. Now we're going to try this one. It says on the grid, show by shading the region that satisfies all of these inequalities. So I'm going to start off doing these two, and I'll do these ones in blue. They are or equal to, so that means we can draw them as straight lines. So I'm going to begin by drawing the line x equals 0. The line x equals 0 is just like this one here, and the line x equals 2 is going to be a vertical line, just like this one. This one's going to be super easy. This is just that y is less than or equal to x plus 3. So I know it's going to go through the 3, and it's just going to have a gradient of 1, which means it is going to look something like this. And then the last one that I'm going to do is a little bit trickier. So we have our 2x plus 3y is equal to 6. Well, we could use my trick that I just did on the other page. We can say, what happens if x is equal to 0? Well, we would get that 3y is equal to 6, which means that y is equal to 2. So that means it's going to be going through that point there. And what about if y was equal to 0? Well, we would have that 2x is equal to 6, which means that x is equal to 3, which means it's going to be going through this point here. So continuing that pattern on, you can see which bits it's going to go through. I'm just going to join those together in a line like this. Not bad. Yeah, that looks pretty good. I could extend that line a bit longer if I wanted to as well. Now what we need to do is make sure that we shade them in correctly. So the first one we're going to deal with is this blue section. It's saying it's bigger than 0 and less than 2. So that means it's in this in-between section that we've got here. We're saying that y is less than x plus 3. In other words, the y coordinates are below this one. So like I did on the previous pages, to these sides here, it's going to be below the black line. And then these are kind of referring to the x and y coordinates are bigger than 6. So anything that is on top of this line, that means bigger than, which means the area that we're actually going to be going for is this bit in the middle, and it wants us to label that area R. This one says the diagram below shows that the region S that satisfies these inequalities. So we've got y is less than or equal to 4x, I think that's that one. Y is greater than or equal to a half x, and then our x plus y is less than or equal to 6. Jeffrey says that the point with coordinates 2, 4 does not satisfy all the inequalities because it does not lie in the shaded region. Is Jeffrey correct? You must give a reason for your answer. So 2, 4 is here, and it's not in the region, but it is actually on the boundary, which is included. So is Jeffrey correct? No, he's not. 2, 4 is on the boundary, which is included, is on the boundary, which is included. If it was a dotted line here, then it wouldn't be included, but it's a solid line, so he is wrong. So we've got this correct region, and then no, 2, 4 does satisfy this, or 2, 4 lies on the boundary of the region, satisfying the inequality sign. Okay, we've got more of these drawing ones. I'm going to start off doing the really easy ones. So this is x is less than 3. So I'm just going to go to 3 and immediately going to just go in with a dotted line instead. But they actually don't mind for this one. I'll show you it in the mark scheme afterwards. Now I'm going to do this one here. I'll do this in like a red colour. So the y-intercept is going to be 6 and the gradient is -3. So that means each time you go one space across, you go 3 spaces down like this. And now we're going to draw this in with a dotted line. Hopefully, if you have a ruler, you'll have this printed out and do a better job than I'm doing of this. Now, this last one, we're going to say that 2y plus 4 is less than x. So I'm just going to make it an equal to, and I'm going to rearrange it to make y the subject. You don't have to do it this way. There are other ways. This is probably just the way I see it. So I've subtracted the 4, and now I'm going to half everything. So the gradient is a half and the y-intercept is -2. Now if the gradient is a half, that means that each time you go across 1, you're going up a half. In other words, each time you go across 2, you're going up 1. So it's going to be going here, 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 like this. Okay. Now I'm going to do all of these as dotted lines. So you're going to continue this one as a dotted line. That is very wonky, but am I going to correct that? No, that's fine. If you have a root, no, that looks so bad. Let's make that look neater. There we go. A little bit neater. Now we just need to figure out the ones that satisfy all of this. So this is saying that the y coordinate is less than this. So because it's a y is less, that means that it's below this line that we've got here. We want x to be less than 3, so it's to the left. And then the y coordinate being less than this means that we're going underneath this line that we've got here. So the only place where it is going to be to the left of here, under the black line and to the left of this, is this kind of weird shape that we've got down here. So we're going to shade this one in, and it wants us to label this region that we've got here R. So the reason they want you to put the letter R in there just is in case the way that you do the shading doesn't show up that clearly. So by putting a letter R, there's clearly only one place that it's referring to, which is that bit there. And you can see that. Notice how it says except full or broken lines for all marks. So actually, even though it's meant to be dotted lines, it doesn't matter if it isn't perfectly, if it's done filled in. And then this one doesn't actually even fit in with this topic. This one comes under like miscellaneous is what I put on the front page, and it's just about understanding coordinates. I had no idea where to put this question, so we'll just throw it in here. It says a pattern is made from 4 identical squares. The sides of the squares are parallel to the axes. They tell us what point A and what point B is, and we want to find out what point C is. Now, I have no idea where this is 5 marks. This is completely crazy in my mind, but let's figure out what's going on. So the AX coordinate, it says, is 6 because it's the first number, and the B's X coordinate that we've got here is 38. So we can tell that the gap between 38 and 6 is 32, and that's corresponding to 1, 2, 3, 4 squares. So if I do 32 divided by 4, that means that the side length of each square is 8. So I can fill all these bits in here with an 8, and because they're squares, right, all of these lengths are all going to be 8. So all we need to do is figure out what is the coordinate of C. Well, if this is a 6 here and we're moving an 8 and an 8 along, the X coordinate of C is going to be, it starts with a 6 and we're adding on an 8 and an 8. 6 plus 8 is 14, plus another 8 is 22. So we know that the C coordinate is going to start with a 22. Now, because this coordinate that we've got, the Y coordinate of B, is 36, and we want to find out what the Y coordinate of C is that we have here, just like I was trying to find the X coordinate of C here. We can see that it's 36, it's coming down 8, and it's coming down 8. So it's going to come down in this place. I'm going to take away 16 to get down to the value, which is 20. So the Y coordinate, it was 36, and we took away 8, we took away 8, and we get the answer 20. So it is 22, 20, is the coordinate for C. Let's just double check that we've got it right. Yep, it is 22 and 20 that we've got here. So that's everything on linear graphs. I'm going to be doing non-linear graphs next. If you found this helpful, please do give this video a like, subscribe to my channel to be able to get access to the rest of all these videos, and let me know if there's anything you need any more help on. Okay, good luck.